Okay everyone, welcome to my channel, and today we're going to be talking about IDEF0. Now if you're like me, you looked at the using IDEF0 prompt on the module discussion page and went, what the heck is that? Well, worry not, because I'm here to tell you it's basically a modeling language, which is fancy speak for creating flowcharts that allow you to graphically represent some functional structure, such as a manufacturing process. And because nobody can ever resist adding too much to a good thing, IDEF is actually a family of languages. There's IDEF0, which deals with functions, IDEF1, which deals with info modeling, IDEF2 for simulation, and so on and so forth up to 11. We won't be dealing with any of that today. We'll look purely at IDEF0 since it's the most basic of the IDEF family languages. Now, having answered what is IDEF0, the question of why is IDEF0 is easier to explain. As the saying goes, a picture is worth 1,000 words, and if you're going to run your hot new manufacturing process by your boss, you'll go much further with a cogent diagram rather than a 10,000 page report on the same thing that they'll probably put down after reading the first page. And because every aerospace problem and solution is always way older than you expect it to be, it turns out people have been facing this problem for a long time, and so the impetus to create IDEF0 reaches back quite a long way. So we start with structured analysis and design techniques, or SAD-T. This was invented in the 60s, back when computer was still a job description instead of a consumer good. And SAD-T introduced the box and arrow format of IDEF0 that I will go into later. Indeed, IDEF0 is basically SAD-T repackaged and renamed by the USAF Materials Lab, who in the 1970s knew a good thing when they saw it and spun off the IDEF cinematic universe with the 11 different IDEF languages I mentioned earlier. Here we also witness what amounts to a marketing war crime, where the USAF Materials Lab decided the only thing better than an acronym was a nested acronym, and so IDEF really stands for Integrated Computer Aided Modeling, or ICAM, Definition, or IDEF. And that brings us to the IEEE, who upon taking over the standard in 1998, took one look at that beautiful nested acronym and decided it had to go. Now IDEF stands for Integration Definition, which is A, more boring, but B, more informative, so I guess I can't really complain. Now, no matter what you call it, IDEF0 has remained functionally the same since it was called SAD-T. The functional building block of IDEF0 is the box format. You have a box for every function in your IDEF0 diagram, and 4 arrows connecting to and from it that you can remember with another acronym, ICOM. Going clockwise, these are the inputs, controls, outputs, and mechanisms. And rather than explain what each of these are individually, let me just give you an example of a welding station in a car factory. In this case, the inputs would be the car chassis parts, controls would include things like the desired line speed, the outputs would be the welded car chassis themselves, and the mechanisms would be the robot arms that perform the welds. In this way, you can model your entire manufacturing process as a series of daisy-chained boxes and arrows. Each box basically represents an intermediate function, and all the arrows represent the flows of materials and inputs from one workstation to the next. Now, because IDEF0 is so flexible and versatile, there's often the temptation to go overboard and do things like assign a function box to every single worker in the factory. If you create such a diagram, it's generally big, complicated, and ultimately useless. So ideally what you want is a repeatable approach that allows you to generate diagrams with only as much detail as is required to convince your boss and secure your raise. So a more robust approach involves starting with a top-level concept diagram. That's the single box and arrow plot you see at the top. The box is the entire manufacturing process, along with all of its ICOM arrows leading in and out. You then start iteratively decomposing the factory box into smaller and smaller subfunctions, finally stopping at the level of detail required. This basically allows you to custom tailor the level of detail to the target audience, which is very helpful. Now for those of you who have done a good amount of software work, this is roughly the same as developing by interface. So you start with a bare bones parent function with no internal implementation and implement subfunctions in deeper and deeper layers until you get the functionality that you want. And there you go. Now you know how to use IDEF0 to chart manufacturing processes. So thanks for listening. Remember to like, comment, and subscribe, and I'll see you next time.